Hello everybody, welcome to the Pioneer. This is my first video and it's about indices. This topic actually appears in both SHS and DHS syllabus. It is an easy topic, but if you find it hard, don't worry because I will show you. Before we move on, please be sure to subscribe, share this video, and either like or dislike the video. Now we can say indices is a short and easy way of writing numbers that multiply itself. For example, 2 times 2 times 2 can be written as 2 exponent 3. In this case, 2 is the base and 3 is the exponent. So to be able to solve a question under this topic, there are some laws and properties that guide you straight to your answer. All you need is to know them. So let's go ahead and list them. In these examples, alphabet will sometimes be used to represent bases and exponents. Okay, fine. The first law I would like to show is the multiplication law. Let's say we have a base x and an exponent which is 3. Multiplying the same base x and an exponent which is 2. This law states that when the bases are the same, just repeat the bases, and when they are multiplying, add the exponent. It is as simple as this. Be sure, please take note that these bases must be the same before it works, because it does not work for different bases. You have to make these bases the same before you add the exponent. Fine. Then let's quickly move on to the next one, which is also the division law. And this law also states that we have a base x with an exponent 3, dividing the same base x with an exponent 2. This law is saying that whenever indices of the same bases are dividing, please repeat the base and then subtract the exponent to get your answer. Fine. So these laws and properties are actually simple things that you have to know, and you can keep them in your mind. Fine. Let's quickly move on to the third law, which says, supposing we have a base x with its exponent, let's say 5, in a bracket, and outside the bracket there's another exponent, let's say 2. It is saying that repeat the base and multiply the 2 exponents. So in this case, it is x exponent 5 times 2. X with the exponent multiply 5 times 2. Okay. Now let's move to the next one. The next one is something like this. Supposing we have a number x dividing another number y. Both of them are in bracket, or they are in brackets. Then above we have an exponent, say z. Then this property, this is actually a property which is saying that because the x divided by y is in brackets, then the z will apply for both of them, or will affect both of them. So the result will be x exponent z over y exponent z. Then you can find them and then divide, then you get your answer. Let's quickly move on to the next one. This one is also saying, supposing we have a base, this time let's use y as the base and an exponent of 1 over 2. Then they are saying it's equal to, because the exponent is half, then it will be the square root of the base. Since it is half, square root is used. But for 1 over 3, supposing it were to be 1/3, then we would rather use the cubic root. Fine. Let's move on to the next one, which is also saying it's something like this, but in this case x over y, still in brackets, but in this case the exponent is in negative. This property is also saying that when the exponent has a negative and the base is actually a fraction, then the fraction base just switch positions so that the negative will disappear. So it will be something like y over x exponent z. You see the y now is above and the x is now below. So they just switch positions so that the negative of the exponent z will disappear. Fine. The next property is saying we have a base. Let's assume y with an exponent 0. Then they are saying that it is equal to 1. This one is actually simple. They are saying any number with an exponent of 0 is equal to 1, irrespective of the number. Okay, so basically they are saying that any number with an exponent 0 is equal to 1. Okay, let's see what the next property has for us. It is saying that a base, let's use y, with a negative exponent, let's say negative n, is equal to what? Because of this negative, it means 1 over then the base with the exponent, the positive. The exponent will no more be negative, but this time it will be positive. 1 over the base and then the exponent, which is now positive. Okay, then let's move to the last and not the least, which is saying two numbers. In this case, let's use x and y. Whether they are adding, subtracting, multiplying, or dividing. But in this case, let's just assume they are multiplying. So x multiplying y in a bracket. Please note, in a bracket. And then outside the bracket is an exponent z. This property is saying that because x and y are in a bracket, then the z affects both of them, just like the z affected both of them here. So it will now be equal to x z exponent z and y exponent z. Fine. Now that the rules of the game is clearly spelled out, let us take a look at some super easy questions to strengthen our foundation on the basis and to know how it is used. So the first one I would like us to solve is 5 exponent 4 times 5 exponent 5. Maybe in an objective question you may come across this, but there is nothing to waste time on. So from from this property that we've learned, the first one, then we could see that when they are multiplying, repeat the base, and this in this case the base is 5, and then add the exponent 4 plus 5, which will now give you 5 exponent 9. Now what if we meet something like this? 5 exponent 7 divided by 5 exponent 9 is equal to, we have also looked at a law which says that when they are dividing, repeat the base and subtract the exponent, and that's exactly what you should do. Repeat the base and subtract the exponent. Okay, then you may also come across this one too. 8 squared into brackets, then exponent 3. Here is also simple. Write down the base, write down the first exponent, and multiply to the second one. You get your answer and you put it down. Okay, fine. What if we come across this one too? Let's say 3 over 2 in a bracket, then exponent 3. This is also something simple. 3, since the 3 divided by 2 is in a bracket, then the exponent 3 affects both this and this. So 3 exponent 3 over 2 exponent 3. You find your 3 exponent 3 and put it here. Find your 2 exponent 3 and put it here, and then you find your answer and you move on. Now, what if you find something like 5 exponent 1 over 2? This is also simple. This something like this is equal to the square root of 5. Find the square root of 5 and then you move on. We will also come across something like this. 6 exponent 0. Okay, this one is very easy. It is equal to 1. Any number exponent 0 is equal to 1. So 6 exponent 0 is equal to 1. It's not an exception to the rule. Now, what if we come across, let's say 2 exponent negative 3? Okay, fine. This is also easy. Remember what we saw here. So it will give you 1 over 2 exponent positive 3. Unlike 2 exponent negative 3, now it is 1 over 2 exponent positive 3. Then you continue your calculation. You may also come across this one during your calculation. 3 times 2 in a bracket, then exponent 2. Remember the last one. So you just move on and do something like 3 squared times 2 squared. Then you move on. Fine. Now that we have successfully put together all the laws and properties, I hope you now understand how to use the laws and properties to get your answer, at least basically. But the questions we just solved are not standard questions. But in my next video, we shall solve together a few standard questions that will further broaden your mind and make you become like a beast at solving such questions. Be sure to subscribe, share, and like or dislike the video. And if you have a question, please let me know down in the comments. So go therefore and solve more questions, remembering these laws and properties I've given you, and always remember to be calculation minded. Enjoy the rest of your day.